let's plot the sine and cosine functions, also known as the sinusoids. Both sine and cosine are both known as sinusoids because they're identical twins. Okay, so here's a Cartesian coordinate plane, and we're going to have the independent variable be in radians. Okay, so first we want to put in the range of each axis. So there's x, y, but what's the range of x going to be here and the range of y? Well, okay, what's the range of both sine and cosine? Well, we know that they both oscillate between -1 and 1. No matter what the input, neither can ever be greater than 1 or less than -1. So let's put the maximum and minimum output values as plus and minus 1. Okay, now we also know that the sine and cosine functions are periodic with period 2 pi. So let's go from 0 to 2 pi in the positive x direction, and then 0 to -2 pi in the negative x direction. Okay, so let's say that this is minus pi and this is plus pi, and then we want to go another, okay, and actually we can let's mark off some midpoints here too. So you've got, and then 1, 2, okay. Yeah, let's do the same thing on the vertical. Let's put in some intervals. Okay, so let's see, halfway is 2.5. And then 1.25 is, so and then 5, 10, each 12 ticks is 1/4. Okay, there we go. So this is 2 pi, and this is minus 2 pi. And let's see, you get minus pi and pi. Okay, so now let's make a table with some input angle values and the corresponding sine of the angle. We'll graph sine first, then we'll graph cosine. Okay, so we've got the input angle x and the corresponding sine of x. And what we're going to do is the input angles will do the special angles and any non-acute angles that have reference angles equal to the special angles. So let's draw the reference 30, 60, 90, and 45, 45, 90 triangles. But let's convert the angles to radians. So 30 degrees. So pi over 6. And then 60 pi over 3. Okay, so this is, okay, now the 45, 45, 90. So 45 degrees. This is 1. So pi over 4. Okay, so we'll do the special angles, or any angle with a reference angle that's a special angle, and the quadrantal angles. So sine of 0 we know is 0. Now next is 30 degrees. That's opposite over hypotenuse, 1/2. Okay, 45 degrees is 1 over root 2. And if we rationalize that, that's root 2 over 2. Okay, now 60 degrees is opposite of hypotenuse, root 3 over 2. Okay, now 90 we know is sine of 90 is 1. Sine of pi over 2. Okay, so now what's next? That in degrees, that would be 120. So 120. So 2 pi over 3. Okay, now, so what's the sine of this angle? Well, there's two ways we can do this. We know this is, the reference angle here is 60 degrees. So we could come to the 60-degree angle and do, so opposite of our hypotenuse, but just keep in mind what if the side length is going to be negative or not. In this case, it won't be. Y is positive in the second quadrant, so this is going to be root 3 over 2. But also, if we think about the unit circle, we know that any angle with a reference angle of 60 degrees is going to have the same height as the 60-degree angle, either in the positive or negative direction. The height magnitude is going to be the same. So with that, we just have to think about what quadrant we're in and whether or not y is positive or negative, because we know that sine is the y coordinate over the radius, the hypotenuse. Okay, so next is 135. So this is, we got 3 pi over 4. So this is going to have the same height as the 45-degree angle. This reference angle is 45 degrees. And we're in the second quadrant. Y is positive, so root 2 over 2. Okay, next is 150. Okay. So reference angle is 30 degrees. We can come here. Here's 30 degrees. Opposite over hypotenuse. The y coordinate is positive, so 1/2. Okay, next is pi, which sine of pi is going to be 0. Okay, 180 plus 30. Next is 210. So that's 7 pi over 6. That reference angle is 30 degrees, but we're below the x-axis, so this is the y-coordinate's negative, but it's the same height as the 30-degree angle is above the x-axis, so here's the 30-degree angle, so it's negative 1/2. Okay, continue over here. Next is 240. 18 divided by 6 is 3. 24 divided by 6 is 4. Oh, well, that's actually, this is, I skipped the 45 degrees. So this is corresponding, this has reference angle 60. Okay, so let's just, here's the 60-degree angle, opposite of our hypotenuse, but now the y-coordinate we know is negative. Okay, so now let's come back. So 225, this is 5, so, okay, so 45 degrees, come here, it's root 2 over 2, but it's going to be negative. Okay, and then 270, that's quadrantal angle, 3 pi over 2, that's negative 1. Okay, 270 plus 30 is 300. 30 divided by 3 is 10. 18 divided by 3 is 6. 10 divided by 2 is 5. So 5 pi over 3. So this has reference angle 60 degrees. Let's just use the triangle. Here's 60 degrees, opposite of hypotenuse, but we know that the y coordinate is negative, so minus root 3 over 2. Okay, now let's go another 15 degrees. So now we have reference angle 45. This is 7 pi over 4. Reference angle 45. We could just see here's 45, root 2 over 2, but it's going to have the same value, but just positive or negative, depending on just what the y coordinate is. Well, we know it's negative. Sine in the fourth quadrant is negative, so okay. Next is 330. 33 divided by 3 is 11. 18 divided by 3 is 6. Okay, this is a 30-degree reference angle. I'm just trying to switch up the methods. You can use whatever you want. So it's going to have the same magnitude as the 30-degree angle, the acute 30-degree angle, but it's going to be negative because in the fourth quadrant, sine is negative. Okay, now 2 pi, sine is 0. Okay, so now we just want to plot each of these points as accurately as possible. And we're focusing on the interval from 0 to 2 pi. Each of these points is between 0 and 2 pi. Now we'll need to get, for some of these y values, we'll need to use the calculator to get decimals, like root 2 over 2, root 3 over 2, but the x values were already in terms of radians, so we could just do that visually. So, like for example, okay, there's 0, 0, and then now pi over 6, 1/2. So this is 1/2 pi. This is about 1/4 pi. And actually, let me put some additional tick marks. Okay, so that will make it really easy to get to each x coordinate because, okay, pi over 6. So we've got 0, 0 plotted. Now pi over 6. Oh, let me do this. And actually let's do this as well. Okay, so 0, 0 is plotted. Now pi over 6. So this is pi over 4. Each of these ticks is pi over 8. So 1/6 is about 0.17. 1/8 is 0.125. 1/4 is 0.25. So about right here. And then we go to 1/2. Okay, pi over 4, root 2 over 2. So here's pi over 4. Root 2 over 2 is about 0.71. Okay, that's 1/2. This is 0.75. Each of these tick marks is 0.125. So this is 0.625. This is 0.75. So maybe about right there. Okay, pi over 3 is about 1/3 is 0.333. Here it's just 3/8 pi because we're going 1/8. 1/8 is 2/8, 3/8. 3/8 is 0.375. So 0.25, 0.375, 0.333. So about right here. Root 3 over 2 is 0.866. So there's 0.75. Then there's plus 0.125. So a little bit less than this. Okay, pi over 2 and 1. Okay, 2 pi over 3. 2 over 3 is 0.67. This is 5/8 pi. That's 5/8 is 0.625. So a little bit past this. And then root 3 over 2. Okay, 3/4 pi. That's right here. And then we're going to root 2 over 2. Okay, 5/6. Let's see, 4 pi over 8. Then we add an 1/8, 5 pi over 8, 6 pi over 8. This is 7/8, which is 0.875. 5/6 is 0.833, so a little bit less than this, and we're going up to 1/2. Okay, and then at pi, it's 0. Okay, so now 7 pi over 6, we go to minus 1/2, and so we can see that the pattern here, we go one tick, a little bit past one tick, and then minus 1/2. Okay, then we're going to go to the second tick, and then root 2 over 2 was about 0.71, so right before 3/4. Okay, second tick, and then there's minus 3/4, so right before. Okay, 4 pi over 3 is right before the third tick, so 1, 2, 3 right here, and then that was, what was that, 0.866, so right, let's see, right here. So okay, then 3 pi over 2 was minus 1. All right, 5 pi over 3 is going to be minus root 3 over 2. That was a little bit past for the first tick after the quadrantal angle, so, okay. 7 pi over 4 was, so this is halfway, and that's going to be even with, okay, and then the last angle before the quadrantal angle was, this is going to be, goes to minus 1/2, and just before the last tick before the quadrantal angle, so about right there. And then 2 pi is 0. So there's 15 or 16 points of the sine function going from 0 to 2 pi, so over one period. Now let's just connect the dots with as smooth of a curve as we can draw. Okay, there we go. Now, to fill out the minus 2 pi to 0 region, we can literally just copy and paste this curve into this region. You can have the exact same pattern going from minus 2 pi to 0. And there we go. There's sine of x. And if you want to go above 2 pi or below negative 2 pi, you just keep copying and pasting the period over and over and over again. Okay, now let's graph cosine. Okay, cosine of 0 is 1. Here's the 30-degree angle adjacent of our hypotenuse, root 3 over 2. 45-degree angle, it's going to be 1 over root 2, so root 2 over 2. The 60-degree angle, 1/2. So we're getting the exact same values that we got for the sine graph. They're not in the same positions like associated with the same angles, but it's going to, just like sine, we're going to have a mixture of root 2 over 2, root 3 over 2, and 1/2, zeros and ones, and then just either positive or negative. Okay, pi over 2, this is quadrantal angle, that's 0. Now we've got the next, this is the second quadrant angle with reference angle 60 degrees. So here's the 60-degree angle, but in the second quadrant, the x-coordinate, like we know cosine is negative, so this is going to be negative 1/2. We can check that here. So here's the 60-degree angle adjacent over hypotenuse, but the x-coordinate is negative 1/2. Okay, here's the 45-degree reference angle corresponding to the second quadrant. So that's going to be minus root 2 over 2. Every cosine value in the second quadrant is negative. Here's the 30-degree reference angle. So here's the 30-degree minus root 3 over 2. Okay, cosine of pi is negative 1. Okay, here's the 30-degree, the third quadrant angle with a 30-degree reference angle. So let's come to the 30-degree angle. Here it is. So this is going to be plus or minus root 3 over 2. Okay, but in the third quadrant, we know cosine is negative. All right. Here's the angle in the third quadrant with a 45-degree reference angle. So it's going to be minus root 2 over 2. All cosine values in the third quadrant are negative. Okay, here's the third quadrant angle with a 60-degree reference angle. So here's the 60-degree minus 1/2. Okay, this is quadrantal angle 0. Okay, here's the fourth quadrant angle, 60-degree reference angle. Cosine in the fourth quadrant is positive, right? It's the x-coordinate is positive. So 60-degree reference angle, that's going to be positive 1/2. 45-degree reference angle, root 2 over 2. 30-degree reference angle, root 3 over 2. And then 2 pi is 1. Okay, so at 0, cosine is 1. And then pi over 6, let's see if we can see the points. Here's the pi over 6 point. And then we're at root 3 over 2. So we can just line these up with the sine graph. So here's pi over 6. And there's root 3 over 2. Okay. Now pi over 4 is here, and that's at root 2 over 2. So these are the same. They cross. Okay, pi over 3 point is here, and we're at 1/2. Okay, pi over 2, 0. Okay, 2 pi over 3, we're a little bit past the first tick mark. And then we go to minus 1/2. 3 pi over 4 in the middle between pi over 2 and pi, and that's minus root 2 over 2. So that's going to be lined up with this point here. And then, let's see, 5 pi over 6 is lined up. We can see here a little bit before, and that's right there. Okay, and then pi is minus 1. Okay, now 7 pi over 6, we can see this corresponds to this point, but we're at minus root 3 over 2, so we're back here. Okay, 5 pi over 4, there's 5 pi over 4, and minus root, so okay, yeah, this is where the two curves cross. Then 4 pi over 3 is let's see, this corresponds to this point here, and we're at minus 1/2. Okay, 3 pi over 2 is 0. And then 5 pi over 3, we're at 1/2, so a little bit past the first tick mark. Yeah, that's where this point is. So then 1/2. Then 7 pi over 4 is at root 2 over 2. Let's see. Here we go. We can use this point. Is that right? Or no, 7 pi over 4 is going to be halfway. So, and root 2 over 2, that's here. 11 pi over 6 is here, and that's root 3 over 2. And then 2 pi is 1. Okay, let's connect the dots. Okay, there we go. Now let's copy this. So I'm literally just taking like a screenshot of this. You literally copy the period and paste it over and over and over and over again, all the way from positive infinity to negative infinity. So this is cosine, and this is sine. Now, in upcoming problems, we're going to learn some shortcut methods for graphing the sinusoids. However, I would suggest that at least once you go through this entire process that we just did here. Do that on your own. So don't use your calculator at all to get the trig function values. Make the full table of values yourself. Plot each point manually and sketch it. Because when you do this all manually from scratch, it just gives you a better intuition for how the graph is built. And also, when you do it from scratch like this, you'll notice, so when I was sketching the graph, like whenever we use the shortcut methods, those methods are fine, but you end up just, you draw a sinusoid just like a squiggly line kind of, which is fine. However, when you actually plot the points precisely like this and sketch it, you really get an intuitive feel for the intricate shapes of the graph. Like whenever I was drawing the curve from like this point to this point, it really feels just like it's kind of like it's a straight line. It's weird. You know, when you draw it rough hand, you're kind of making everything just as curvy, but this region here going from 1/2 to minus 1/2, it's like it feels like its own distinct region. So, I mean, I don't know. I would suggest going through this entire process at least one time, and then any time after that, you can just use the shortcuts.